So in this last video, we're going to analyze the final section of the original sensitivity report number 1 associated with the base model. Okay, which shows that the final value. Let me switch to it, of both the labor and material constraints. Okay, as well as the showing that they're the same as their right hand signs, which means both are binding. Right. In addition to that, it shows something called shadow prices: 20 cents or 0.2 for labor, and $1.20 for, or $1.20 for material, as well as their allowable increase and decrease values, which you by now know how to work. Okay, by adding or subtracting from the parameter. Again, just remember, this all has to be done one at a time. So these shadow prices, okay, as discussed on this slide, have economic meaning that can be an important indicator to management in planning of allocation of resources. Okay, in this particular example, the increase in overall raw material levels from 6 to 7 pounds, right? So from 6, okay, to 7 pounds, which is within the 2-pound allowable increase, okay, will increase the weekly profit by exactly that shadow price of $1.20. So from 9.6 to 10.8, as you'll see once we eventually run it. Okay, this is more than an increase of 20 cents that you could accomplish by throwing in an additional labor hour, increasing it from 12, okay, to 13, which is again well within allowable decrease of 12. We can increase up to 24 hours and have these shadow prices, or this specific one, be valid. Again, one more time, you have to remember that you have to do these one at a time, right? So if you're analyzing the material, you do that first, then you put it back at the base value of 6 pounds, and then you analyze the labor. Also, for a non-binding constraint with a positive slack, the shadow price is always 0. To show that switch to, you should still have that sensitivity report 2, okay, where the labor is non-binding, has the 3 hours of slack. Okay, you can see that the shadow price is 0. Okay, so next we're going to switch to the Excel file and a sheet called right hand side sensitivity. Okay, notice that we will increase the right hand side for material. Where are you? Right here, from 6 to 7 pounds in that bright yellow cell there. Okay, so which is within the allowable increase, for that particular right hand side. Okay, so we must resolve to get the new optimal solution, which you will see in a second, is the 0.63.2, right? So it's more towards top left, because now we have more material available. We can produce more of a higher margin a product or drug too, right? From 2.4 to 3.2, and this one's reduced from 1.2 to 0.6 for the increased profit of I guess it's $10.8, right? So start here. We'll just quickly run the model, add-ins, premium solver, run. Okay, and notice that the profit is 10.8, which is exactly 9.6 plus 1.2, the shadow price associated with that additional pound of material, and this new optimal solution as just discussed on the slide. Okay, the last thing we're going to discuss in this video before the summary is one of the tools available with the Analytics Solver platform, okay, which allows us to show how the systematic changes in a parameter, such as this right hand side for material, which we just discussed, okay, can be sort of summarized and sort of the impact on optimal solution, which is these two columns, and profit, the last column, captured. Okay, so first we'll switch to the last sheet of this Excel file. Okay, and we'll choose any empty cell like this. F5 is as good as any. And under Analytics Solver Platform, Parameters, Optimization, we'll set up a parameter with a lower bound of 3, which is 3 pounds. At the most we can reduce the right hand side of 6 pounds by, or 2, for that shadow price of $1.20 to be still valid, and then the upper one is 8. You can put a base of 6, or it doesn't matter. And then in D5, I guess in the bright yellow cell, instead of constant 6, you just reference this cell. Okay, now under model, what you might need to do for the variables, you might need to make the monitor value true, because it was false for me when I first time I did it. Because when you go under reports optimization parameter analysis, we want to be able to see both the variables, which are x1, x2, b11, c11, right? The drug 1, drug 2 production, as well as the objective, and shoot them to the right. And also the parameter that we are changing in F5. Okay, because there are 6 different levels, 3, 4, 5, 6, 7, 8 pounds. Okay, we want the major access points to be 6. We run it, run 6 optimization. It's kind of hard to see, it goes by real fast. Creates the analysis report. Okay, I'll just rename the material increases from 3 to 8 pounds, and then drug 1, drug 2, and profit columns. All right, so it shows you starting with the baseline, okay, increasing the availability shifts production to drug 2, which is more profitable, increasing the profit. The opposite happens if you shift the other way, right, reduce the material availability. Okay, back to the presentation and finally the summary. All right, so this concludes the series of a lot of videos, 10 altogether, on the third part of the class on linear optimization models in chapter 13. Okay, this series of video covered the basic optimization modeling concepts and emphasized the fact that optimization is an invaluable tool underpinning a wide variety of predictive analytics problems. We described the optimization modeling process in some detail and demonstrated how to build a basic optimization model for a product mix mini case we've used throughout all the videos. We demonstrated the basic linear optimization concepts both graphically and mathematically, from feasible regions and profit contours to vertices and optimal solutions. I hope the graphics approach made sense and helped you understand the basic linear optimization concepts, some of which can be a little tricky. We then discuss how to represent the mathematical linear programming model in a spreadsheet with data, constraints, and objective function sections, and then we demonstrated how to solve it with the standard and premium solver. We also discussed some of the special cases, such as the alternative optima, unbounded, and infeasible solutions, the later of the two often coming from model misspecifications. We used the answer report to discuss the concepts of binding and non-binding constraints with slack at the optimal solution. The sensitivity report showed us the allowable ranges for objective function coefficients within which the optimal objective function changes, but the optimal solution stays the same. Finally, the shadow price for the constrained right-hand side represents the increase in the objective function for the unit increase in the resource availability, which can provide management with valuable information on what effect increases in the resource availability would have on the bottom line. We concluded by showing how to use the Analytical Solar Platform's parameter analysis tool in the context of shadow price example with a material constraint. Next, we are going to discuss these concepts on some other examples in class, as well as in our next homework assignment. More complex, moderately complex applications of linear programming models will be covered in the next series of videos on a variety of examples from Chapter 14.